Section 13.2, if you remember 13.1, it was about linear measure. It measured the length of things specifically. In 13.2, we're going to measure area. So one way that people will describe area sometimes is the space inside of something. So we're specifically going to be looking at polygons and circles in this section. And we're going to define the area as the number of non-overlapping squares of a particular size that cover a region. So kind of imagine our tessellating, tiling kind of things. So we've got a specific size of a square and it's covering a region. Because we are measuring in squares, our units are square units. Okay, that's why that happens, is because we're measuring it in squares. All right, so real basic one to start with. What is the area of this square grid? What is it? 9. Yeah, don't overthink this. It's 9. And then when we're writing down our units, whatever they are here, because we aren't told, like, is it feet, is it centimeters, is it inches, we don't know. We're going to say units squared. Whatever it is, it's square units we're measuring in. If we were given more details, we would put more details. I don't have any. We probably should invest in some if we could find some cool projects to do with them. I wish I would. But have you ever played with a geoboard before? You guys seen a geoboard? A geoboard looks like, in fact, let me flip over here just so you can see it. It looks kind of like this with those little black dots that they're being pegs. All right, have you seen it when they have pegs and you use rubber bands with it? That's called a geoboard. So a geoboard or dot paper, which is what we're using, can help us think about area. And we're going to look at that area in a very visual way from that perspective. So the addition method is one of those ways, and the area is found by adding the areas of smaller pieces. So if we looked at this shape, and you wanted to imagine, like, putting those rubber bands around it so that it trapped in areas that were nice things. Like, this is not a nice shape that's shaded in, right? I don't even know what it looks like a bird or something. I'm not sure. But we got something weird going on here that measuring the area for is not very straightforward. But what we can do instead is that we can block off squares. That wasn't what I wanted to do. Told it to change it to a square. So if you imagine right there putting that sort of rubber band around it, that black right there, that blocks off a square. How much area is inside of that square? 9. It's actually the same kind of square that we had just a moment ago. This is 9. And we can keep doing this process with different imageries that are here. There's lots of different ways we can do it, so if your imagination is not blocking things off the way mine is, that's fine. Just use what you've got. This is another square that I could use. What would the area of this square be? Yep, this one would be 4. I can find individual squares, so if you want to count individual squares, you can, right? So, whoops, like here's 1, here's 1, here's 1, here's 1. So you can count them up individually if that helps you better. You could have made other shapes of those instead too. They were a little bit more all-encompassing, but those are all 1s. So far, all the numbers that I've written in, I have 9 plus 4 plus, and I had 1, 2, 3, 4 1s. That's what I have so far. Agreed? And what I actually have left on this particular diagram is a bunch of triangles. But how do those triangles compare to the size of the squares? 2 of them equal 1 square, right? All of those triangles are half as big as a square. Now that wouldn't have to be the case. I could have drawn triangles differently, in the original shape had my shape been different. But this one that it does. So if you imagine, kind of like the way you just said, Julie, grouping these two together, right, shifting them or whatever, that's another, when grouped together, these two give me another 1 unit. And the same thing on the other 2 over here. This one and this one combined to give me another 1. Okay, so we're sort of breaking it down and breaking into smaller pieces that are easier to manage. How much do you get if you add them all together? 19, and you even said that, fabulous, units squared. So that's called the addition method of breaking all of these pieces and adding all the results of the areas together. There's another method called the rectangle method. Still thinking about our Geoboard or our dot paper. And what you do is you construct a rectangle around the given shape and then subtract off the extra area. This method is particularly useful when the given shape contains very few full squares. So the last one we did had lots of full squares everywhere. But if you were thinking about this perspective using that problem, what you would do is you would have to do the rectangle around the entire outside box. And instead of counting up the shaded part, you would subtract off the dead space white part. Okay, so let's do one that actually has that sort of feature to it. So there's no full rectangles here, like squares that I can box in like I did before. Like it's not even a thing, right? So the addition method wouldn't work for this like at all. It just wouldn't. So if we were to put a rectangle around this, it needs to be as tall as my shape is, right? And it needs to be as wide as my shape is. So my rectangle will end up looking something like this. That would be the large outer rectangle. And again, the reason I would do that is because I now see lots of boxes that I could take away, whereas before I couldn't really find lots of boxes that I added up to making the shape that I had. So if you imagine then taking away boxes, so let me take another color. Let's use red. So here's a full box, here's a full box, and here's a full, that's not good. Here's a full box. So those are all full boxes, right? Oh, there's one more up here. So what is the big outer shape of the whole rectangle as a whole? Is it 16? I think it's 12. I think it's 4 wide and 3 down, so I think we've got 12. And right now I have taken off from it in red 1, 2, 3, 4 boxes. So there's -4 from my red boxes. Now, we're still looking somewhat for an approximation. So if I'm boxing something together and I'm looking for sort of overages and underages, if you will, that's a terrible word. But if you imagine sort of taking and trying to fit in, I'll use a different color, we'll use blue, a box here, this amount that it's sort of over, like, gaping over, almost balances out the amount over here. Can you picture that? So when you're looking at this space right here at the top, this space here at the top looks like it's about another 1 that I'm taking off. Okay, now we may or may not have the ability to do that and piece those together. I think I have one more down here I can do that with, or at least really close. I think if I do these two together, I have the same thing. It looks almost like the same image as it on top. It's not quite the same, but it's pretty close, where there's an overage and an undering, right? So if I tried to do the box here, it would overestimate this piece, and then I would have this piece over here that are balancing out around that, so that would be another 1 that I could take away. So this whole box here would be another 1 to take away. Other pieces don't quite balance as well, but they're not too bad. I think that this piece right here and this piece right here look like they almost make up a 1. They're maybe a little bit over. We're approximating here. We all recognize this is an approximation with this, but it looks like it's pretty close to 1 with my orange. And then down here at the bottom, again, my rectangle is not perfect, but it looks a little bit like I have more than that. So if I look at taking this box, it's only a tiny bit over. It doesn't really balance this little bit with this bits, right? They're not quite the same. So if you're estimating that, you need something maybe a little bit more than 1. So maybe you're doing, maybe it's 1.5 that you think it is. We're ballparking here, right? So this is all shaded in blue here at the bottom for what's left. And what I'm left with is the trapped sort of boomerang looking shape on the inside. So if I take 12 and I take away 4, 1, 1, 1, and 1.5, what do I get? Anybody catch it? Yeah, 3.5. So again, it's square units because I don't have any measurements given. I think that we'll stop right there. We've got to break in sort of the text and the content that we're doing when we move into the English units of area after that. So I will post a video, or I may actually re-record it depending on how it's posted because I don't remember what I've done before. But I'll get a video posted for the second half for sure by Wednesday, since that's when you would have to do it in class, typically speaking, so that you can watch that and catch up.